Methanoic acid is found in stinging nettles. In an analysis of the concentration of methanoic acid, a solution is extracted from the nettles. The solution was titrated with a standard solution of potassium hydroxide. Aliquots of the methanoic acid. So what we're trying to find out is the methanoic acid down here, meth with 1, carboxylic acid, were transferred to a conical flask and titrated against a potassium hydroxide solution. So we've got potassium hydroxide up here in a burette. Which one of the following would cause the calculated concentration of methanoic acid, what you found out about this, to be higher than it actually is? So you need to write your equation. So we've got potassium hydroxide, methanoic acid. It's the H from here, carboxylic acid, this hydrogen and that hydrogen get together to make the water, and then your positive cation, and this whole thing has become an anion, makes a salt. So you know the concentration of this, what's in the burette, and you're trying to find the concentration of the methanoic acid. So the first one is if you rinse the conical flask with deionized water. So if you rinse this with water before you started doing your reaction, there would be no change because you're adding moles to here and you're adding moles to here, and then they're reacting in here. So it doesn't matter if they're floating around in more water, because as long as you're adding the correct number of moles. So the next one, rinsing the burette with deionized water. So you should always rinse the burette with whatever's going to be put in it, and the pipette with whatever's going to be put in it. So if you rinse this with water, then you dilute the potassium hydroxide, which means that the concentration of the potassium hydroxide goes down. So the volume that you would need to get the same number of moles to react with this, because it'll be the same number of moles in here, the volume that you need must go up of that. The thing is, you would not know that the reason that the volume was larger than it should have been was because the concentration had gone down. You wouldn't have known that the concentration had gone down if this was an error. So if the volume was large, then it would imply that the number of moles in there was large. If you're using a large volume, then it implies that you're having to put a large volume in here, so that you have a lot of moles in here, because the number of moles in here, so of your unknown, because it's a 1-to-1, if you're having to have a lot of moles of this, then you must have had a lot of moles of methanoic acid to react with. So if this number goes up, then your concentration has gone up. So strangely enough, if you dilute your whatever's in the burette, so the known that was in the burette, then the concentration of your unknown has to go up. And that is the one that we're trying to find, which one will actually be higher. So it's B. Rinsing the pipette with deionized water. If you rinsed this with water, then you would dilute the amount of methanoic acid that you put in there. There would be a lower concentration and a lower number of moles in the same volume. Lower concentration, so a lower number of moles if the volume is the same. So if there's a lower number of moles here, then you'd have to add a lower number of moles there. You'd have a lower volume. Lower volume, same concentration, would be a lower number of moles here, and which would end up, by the time you worked it out, you would find that if you diluted this, you would work out that it was a diluted concentration. If you rinse the conical flask with potassium hydroxide, so if you accidentally put potassium hydroxide in the conical flask, then these two things will react together and you will have less of this in here, so you will need less number of moles. So a lower volume will mean less moles, will mean a lower concentration. So these two things give you a lower concentration. This is the one that gives you a higher concentration.